Hey, Jody here with weldingtipsandtricks.com. Today we're talking about basic MIG welding. This is kind of going to be a how to MIG weld series starting from scratch. I'm going to try to go ABC 1, 2, 3 starting at ground zero. MIG welding, even the term MIG welding is, not proper. Gas metal arc welding is the proper terminology. I don't like saying that many words. Everyone talks about it, refers to it as MIG welding. That's what we're going to do. Let's talk about the nuts and bolts of this stuff. Let's talk about how it works, and we'll see where this goes.
I've got this little 210 MVP welder sitting on this big 2-bottle welding cart that I built recently. It's just sitting here temporarily, but I want to talk about this multi-voltage plug for a minute. It's really easy to swap from 115 to 230 volt. And it's a really good idea for, somebody that is starting out that doesn't right now have 230 volt power but wants to get it one day. And it just allows you to use it for a 115 volt welder, and it's a really strong one. And then when you do get your wiring done, you just swap plugs in and you got the full power of the machine. So
this particular machine has a welding guide, a chart on the inside. A lot of machines have that, and it's nice to have. It can save you a little time. It's not the Bible. It's not carved in stone. It's not going to work for everything. It's just a starting point. But a starting point is a good thing to have rather than just going, playing blind archery, right? So, for instance, today I'm using 7525, 75 argon, 25 CO2, and I'm using 030 wire. That's 0.8 millimeter wire. And I can look on the chart, and it's gonna give me some recommendations just depending on what thickness metal I'm welding. Say if I was welding 1/8 inch thick, which is 3.2 millimeter thick, my settings would be 4 and 40. This doesn't read out on the front here. Doesn't read out an actual voltage or actually inches per minute of wire feed speed. It reads out just numbers, arbitrary numbers, and a lot of machines are like that. The settings on the front don't really mean anything other than a scale, a reference point. And you go from there. Eventually you learn. And by the way, 030 is probably the most versatile size wire. That's 0.8 millimeter. It's probably the most versatile. You can go all the way down and do some auto body panel type work, and it does okay on really thick stuff too. If you're only doing auto body, you're going to be better off with 024 or 023. Same thing. If you don't have a chart, we'll talk about that. We'll talk a little bit about how to set the machine if you don't have a chart a little bit later on. So the spool of wire here, and this is 030 wire, 0.8 millimeter wire that I have on here, ER70S6. Got a lot of silicon content in it it helps welding over a thick mill scale and stuff like that. The silicon scavenges the crud and floats it to the surface, and that's why you see all those little brown islands on the surface of the weld when you're done. That's what those little brown things are, and that's why you want to wear eye protection when you're MIG welding, because that stuff pops off. Been to the nurse's station before with a hot piece of silicon in the eye. So wear your safety glasses under your helmet. You can avoid that. Okay, there's a tensioning mechanism right here on this spool of wire. This got a little kind of a self-locking nut with a washer and a spring inside there. Now, you want to have that just tight enough to avoid backlash. When I press the trigger on the machine here, wire is going to come out the end of here, and you can see the spool move. If I have the wire feed speed set up fairly high, you can see how quickly it moves. Well, I want to have this thing set just tight enough that the spool doesn't keep traveling when I let off the trigger. Just that tight, no tighter. Any tighter, now I make it hard on the drive rollers to pull that wire. It's already got to push it through this cable here. I don't want to make it pull something that's really tight either. It's kind of like a bait casting reel, If you set that backlash thing knob too tight, you can't cast for crap. But if you set it too light, you're going to get backlash. So this feeds the drive roller mechanism right here. These drive rollers on this particular unit are spring loaded, and they pop right off. And one is knurled and one is smooth. The knurled one is for flux core, the smooth one is for solid wire. I'm using solid wire here today. Flux core is a topic for another day. You want to have the correct size drive rollers for the size of the wire you're using. These drive rollers will work on 030 or 035 wire. If I'm going to go down to 024, I'm going to do myself a favor in getting the correct drive rollers for 024. The groove on here might be too deep for this solid wheel to even pinch and get a bite on it. Okay, and if it slips, if I'm slipping here, either because I got this too tight, or because I got too many kinks in my hose here, or because I have a crapped up contact tip, if the drive rollers slip because they can't push it, either because there's too much resistance or it just can't bite on the wire because you got the wrong size wire, it's going to weld like crap. It's going to weld inconsistent. If it welds inconsistent, you're going to be chasing your tail, setting wire feed, speed, and voltage, and all it is inconsistent feeding due to wrong size drive rollers or some other issue like I just mentioned. So while they say MIG welding is so easy a monkey could do it, there's lots of little things that can go wrong. It probably is the easiest way to just get started welding, point and shoot, so to speak, and stick a couple of things together, but it's just as hard as anything else to do well. So I've pushed some wire out here. Now I can either snip this and waste the wire. There's no point in doing that. I take my tensioner off here, off the drive rollers, and I can just retract. Ah, so nice. You only want enough tension, it's like aspirin, you know. Enough is enough. So you want to have the tensioner screw here tight enough to feed wire. And here's the way I do it. There's lots of ways to do it. You can put it against the 2x4 and see how it curls it and all that kind of stuff. But what I do is I put a glove on, and then I hit the trigger and I pinch the wire. See, right now I've got it set really loose, and I can completely stop it by pinching it with my glove. About 2 or 3 little turns, and I pretty much can't stop it. I can slow it down, but it's pushing it through. That's kind of where you want to be. You can slow it down, but it's still feeding. That way you'll feed, but you won't wear out your drive rollers prematurely, and everything will go lovely. So I'm going to retract again.
Another thing worth mentioning, and it's on the chart here of this welder, but it's not mentioned on every machine, is that different polarities are required for solid wire versus flux core wire. There have been a lot of machines that have been sold on Craigslist because people didn't think they welded good when all it was the polarity was wrong. So make sure you're using electrode positive for solid wire and DCEN, electrode negative, for flux core wire. And on this machine, all you do to swap polarity is just make sure that the wire going to the power block there is the correct one, and you just swap them if they're wrong. Undo the little terminals and swap them out, and that's all there is to it.
This is the ground clamp that comes with this particular machine. It's crap. Okay, it's like a dollar store set of jumper cables or something like that. MIG welding, especially more so than other processes, MIG machines need a really solid ground, not an intermittent ground, not a ground like if you lay this on the table and you can see it getting hot in places and sparking here and there and all that kind of stuff. Here's the deal, okay? A basic MIG welder like this, it feeds out wire and you got a voltage setting. There's no internal sensors to tell when you lose your ground to stop the wire from feeding for a microsecond or something like that. It keeps pumping out wire, and so you get that drive-by shooting sound, you know. You start, you get rough starts all the time, you pap, 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 and before you finally picks up a good ground and everything's smooth, and you're like, wow, what's up with that? Or you're welding along and it just stutters here and there, you know, and you go over and you adjust the voltage, you adjust the wire feed speed. You just need a good ground. Now, if I have a crappy ground like this, oftentimes I'll take a little bare wire and kind of make it better. I'll clamp the bare wire onto the workpiece, and now I've got hundreds and hundreds of little contact points that will keep me from losing a ground. And now, instead of, you've got all these little contact points touching the metal on this copper here, as opposed to this copper flashed steel thing that sometimes even when you light up, you can see it arc before it ever establishes a good ground. You see a little tooth get red hot or something like that. So while this might be ugly, it sure does work.
Another thing that's really important is your stick out. And the stick out a lot of times is controlled by how close the contact tip is to the end of the nozzle. And I like them flush or even sticking out just a little bit for the most part. You'll get machines where they're recessed back in there a good 1/4 inch, and sometimes you have to either buy a new tip, a new contact tip to make it longer, or even trim the nozzle. I have trimmed a lot of nozzles. I trimmed this one just a little bit to get it like I want it. For me, it's worthwhile. A short stick out makes a big difference with short circuit MIG welding. Tip is recessed a 1/4 or 3/8 back up in the nozzle. You already got that much of a stick out, and then if you're doing like a T-joint where you can only get your nozzle in there so far, you're going to have too long of a stick out and the machine's just never going to weld like it should weld. This is one style of flow meter with the dials indicating the flow rate, CFH, pressure on one side, and flow rate in CFH, or liters per minute also could be on the other side. But I prefer the ball type, the floating ball type. I found that they tend to be more accurate, but this seems to be a good one. It's a quality regulator from Harris. Well, I'm using 75-25 argon CO2 gas, and with that small nozzle you saw just a second ago, I can easily get by with 15 CFH indoors.
All right, what you're looking at now is just the front panel of the Hobart 210 MVP. You got two settings. Okay, you got voltage and wire feed speed. Now this particular machine has what they call tap settings on voltage, which means it's kind of like an old-timey channel changer on a TV. And you don't want to change it while you're welding, but basically it's click settings from 1 to 7. Okay, it's not considered to be like a great feature to have click settings as opposed to infinite settings. This isn't what's known as an infinite dial, which means I can bump it just a tad, just a tad, just a tad, and really dial things in. For most people getting started MIG welding, this is not a problem at all. Not a problem. Okay, it gives you straightforward settings on the chart, and you can make the adjustments, the fine adjustments here to get a smooth arc. So I don't find it to be a very big drawback at all.
What I'm going to do now is just run a bead. I've got this machine set at 4 and 40, just like the manufacturer's recommendations chart said. And I'm going to be using just a little technique that I just kind of like my go-to technique for MIG beads, and that's just kind of a series of cursive E's or U's, depending on how you perceive it. But it's a pretty good setting. There's not a lot of spatter. You can see a little bit of fine spatter. It does sound very consistent. And it produces a decent bead, and it could be better with a little adjustment of technique. Right now I'm going to lower the wire feed speed down to the 25 setting and listen to the difference in sound. You got a little rattle sound there, and also you look a little at the top member of the T-joint, there's a lot more spatter. And spatter is just basically sort of like a carburetor that's not mixed, that's not adjusted well. You got an inefficient burn, an inefficient transfer of metal. So you've got spatter being expelled outside the puddle, and it can happen from too little wire feed speed or too much wire feed speed. All right, we'll look at that in just a second. You can see there's quite a bit of spatter on the top member there from turning the wire feed speed down to a setting that's pretty low. Now we go all the way down to 20, just a little bit more, and we start getting this hissing. It's still welding, still got a puddle going, but definitely not an efficient burn. Don't have anything close to a bacon frying sound. That's because that wire is burning off and almost burning back to the tip at times before it finally reaches the puddle. This is not good. Now we're looking at too much wire feed speed, all the way up to 60, and actually it's freezing the puddle to where that puddle looks almost like pudding or jello or something. It's more viscous or thicker because there's just pumping too much wire feed speed in there, and the arcing doesn't provide enough heat to make it wet out. So this is not really a good situation either. Will be coming pretty soon, so if I skipped over something, please leave a comment and I will try to cover it before I get finished with this series. It's going to take several parts because we're going to go over different type joints and different positions and all that stuff. We'll see you next time.